recording. And I see we have quite a few different agenda items listed for today. Do you want to start with the declarative node maintenance? That's the first thing on the list.
Okay. Hi. So to make it short, I would like to bring attention to my two caps, which is the declarative node maintenance and evacuation API. In short, the node maintenance is basically a better version of kubectl drain, which is declarative, and evacuation API is a better version of eviction, and it is also declarative. And it has many new features, and it basically so the impact on like the SIG scheduling or autoscaling is that these features could be used, for example, by the cluster autoscaler to basically enact a drain on a set of nodes, and a lot of the logic would be handled by the node maintenance. So, for example, the selection of pods which would be drained, like the order of them, and the evacuation API also has features which help to basically get a earlier signal for the eviction, so the termination of the pod does not happen initially. And basically there can be like a set of hooks that different components can use. They can intercept the eviction through the evacuation API and can have like a special handling for evacuating the pod from the node. So, for example, this could be used by the horizontal pod. Yeah, go ahead.
So I just wanted to queue up for question maybe once you're finished.
Okay, sure. So yeah, so for the evacuation API, this could be used by the horizontal pod autoscaler, for example, to get an earlier signal for example, we could have a one replica application, and if you see that there is a scheduled evacuation or eviction of the replica, the horizontal pod autoscaler could scale up to 2 replicas, wait for the second replica to become available, and then the first replica could be evicted. So you could actually run one replica application, and you could move it from one node to another without losing any availability. So that's like one of the use cases. Yep. Questions?
I'll take start. So this seems quite interesting. It's something we've been like having a lot of iterations on in cluster autoscale, and I think we'd love not to have to do it. One thing I was curious. Actually, there are two questions, but like the technical one is there some sort of ability to limit how long this can take, or have a timeout where we basically like abort the drain if it doesn't finish within some time, or we can specify maximum duration. So just as an example, right, in cluster autoscaler today, we limit maximum graceful termination that we respect for pods, because essentially we have a worker pool that's performing the drain, and it can be saturated by a few pods that just have very long graceful terminations. Is something like that possible?
Okay, so
Mhm.
if I can. So like we have like two scenarios here, like the main scenarios we are trying to solve. So one is like for two actors. One is the cluster admin who wants to like the workloads to be removed as quickly as it possible, and to have a good observability of the process. And then we have the application owner, and they want to have the highest availability. And so regarding the timeouts, we have actually use cases that it's hard to like come up with a value for a timeout that we would abort the evacuation to actually fit this for all workloads like in existence. And this is hard to do for us, and it's hard to do for the admin to actually know this value. So we have a progress timeout that we have an pod and an evacuator, and the evacuator is implemented by us or by a third party. It doesn't matter, and we actually want to have a good observability. So we say to the evacuator, you should report progress on the evacuation in such a couple of minutes. And if no progress happens, we will try to evict your pod like forcefully. But we will so we have the progress, and we know if like something is happening, but this progress can be updated as many times as the application wants. So one of the use cases is, for example, if you have a storage migration, and you cannot evict the pod until the storage migrated, and this can take a long time, a couple of hours, even days. So yeah.
I see. Okay, that's very interesting. I have to look at the cap and the details, and maybe I'll also ask some other people. But yeah, that seems quite interesting in general. I think we need to learn more. I also wanted to ask you about the timelines. So, when is this coming in Kubernetes 131 or later?
Yeah, so I would like to target the evacuation API for 131 if I can get all the reviews and everything through. And for the node maintenance, I think it's better to wait at least for 132.
Sure. Okay. We probably will want to. I guess we want to look at the API and kind of see if it works for us and have any comments. But like in terms of implementation, I imagine we will probably do it once it's available. But that is very interesting, and I'll make sure to take a look. So yeah, thanks for bringing it up.
Yeah, cool. Thank you.
I have a question too. Does this have any impact on the existing, eviction logic, referring to, pod QoS and pod priority, stuff like that? Or is it just preserving the existing logic?
Yeah, so we are trying to use the existing primitives like the eviction or the pod disruption budgets, but we are not trying to change any logic how everything works in Kubernetes today. At least not in alpha. We will see in beta if something is needed.
Okay, and where the links in the document they lead to the description of the APIs, or
yeah, the APIs themselves are in the cap. Yeah.
Okay, I'll find that. Thanks.
Yeah, sure.
Okay, any other questions or discussion of this topic? Okay, in that case, let's move on. The next item is I believe, the discussion of the issues related to cleaning up template nodes in Cluster Autoscaler on AWS specifically. And I believe there is a thread on the Slack to set up a separate meeting for this. There is a survey there, and I've seen that I think trending option was doing it tomorrow, and I don't remember the exact hour that was preferred. Let me check that quickly. Right, it seems the most popular option is tomorrow at 5:30 p.m. Central European time, so 1.5 hour later than SIG meeting today. So I mean, based on the number of people that voted, I think that's probably the time we're going to go for the meeting. So I guess for anyone interested in discussing those issues, you're welcome to join. We will use the normal link for the Zoom. And I expect in-depth discussion. This has been brought on SIG a few times. And I think the conclusion was that we need just deeper level of technical details that maybe fits in this meeting formula. I don't know if we have any other comments to this. All right. So in that case, I want to invite anyone who's interested, and we can move on. I see there is some question around 131 enhancements.
So yeah, I just added it to the agenda so this doesn't get lost while trying to follow up on stuff in the Slack channel. I saw that the enhancement team pinged us for like if there are any planned enhancements for 131, and if not, they want us to confirm that we don't have.
Yeah, thanks for bringing this up. I can see this now. Okay, I'm going to reply. Is there, or just to make sure, is there anything anyone has found? I guess I know we are working on some other, like as part of some other caps that are not really driven by SIG Autoscaling. I mostly think about DRA here, but do we have any enhancements of our own? I know we don't in Cluster Autoscaler. I don't think we have anything in HPA or VPA either, but yeah, if I am wrong on this, please correct me.
Yeah, for VPA, I also don't think there is anything. HPA, I don't know.
I'll double check that then, but I also believe we don't have anything.
Hey guys.
Okay, and if sorry,
New to this, can I get the Slack or the chat link for this autoscaling?
you mean the Slack link? So the Slack is we have a SIG Autoscaling channel on official Kubernetes Slack.
Okay.
And it's literally called SIG Autoscaling. Right, and I think the next item is also yours around VPA updater and admission controller.
Yeah, I filed an issue today about like how the health check mechanism in VPA works. So like there's one thing you want to avoid, that the VPA updater continues to evict pods when the admission controller is unable to actually update a pod's requests, right? Because then you will end up in an endless eviction loop and like effectively everything is down. And like there is a mechanism in place already to ensure that this should not happen, which is the admission controller regularly updates the lease and the updater checks if that lease has been updated recently. But what we recently saw was an incident where the admission controller was being client-side rate limited when like trying to check, for example, the like which VPA belongs to a pod that it's currently admitting. And the lease updates did work often enough such that the updater continued to evict pods. Yeah, and that led to specifically the kind of eviction loop you want to avoid, which brought me to the question, like, should we try to, like, are there ideas on improving that whole thing? Or should we like stop using client-side rate limiting at all? Like, is it actually useful to rate limit that admission controller? Because like if you do and you run into client-side rate limiting, you end up in that situation, right? So I'm not sure what it's useful for. And I like found an older discussion in KK that tries to argue for the same thing. Now that we have API priority and fairness, like, is this really a thing that we want, like client-side rate limiting? Yeah, maybe that's a bigger topic and other people have more experience, so wanted to bring that up.
Yeah, on the client-side rate limiting, I'm pretty sure it dates back to before we had API priority and fairness, and then it was necessary to avoid killing API server essentially. But in theory, it shouldn't be needed anymore. It would probably be good to get some input from people from other SIGs on this, or if there is some sort of broader alignment in Kubernetes, maybe we can get rid of it. I don't know if that would fully solve the issue though, because that seems like a specific failure mode, right? You could probably have similar failure mode, just as an example, by messing up RBAC in a way that doesn't let you update the pods, but lets you write the lease. And
Absolutely.
there is many other ways of getting into similar states. So I wonder if some sort of solution where actually we update lease upon like not having basically we stop updating the lease if error rate or failure rate is large enough, wouldn't be a more general solution. I'm not arguing for not removing the client side limits, right? But I'm just like, that seems like a very narrow fix. But maybe we can have a broader one. But yeah, it seems like issue on GitHub is a good place to discuss this.
Perfect. Yeah, that's already some good ideas for starters. Yeah. It's absolutely true that there are other edge cases where like the whole thing will happen again and like a slightly different flavor. Yeah. So yeah. Okay. Cool. Thanks.
Sure. Any other thoughts on this from anyone?
Yeah, thanks for bringing this up, Marco. We've noticed actually another failure mode just a few days ago that I'll actually go and add into your issue, because it's interesting to think about all these failure cases so that we can hopefully build some kind of resilient solution. So yeah, thanks for starting this, very timely.
Cool, thanks.
Okay, so it seems there is motivation for a more general solution. Let's discuss it on the issue and see if we can come up with something. Okay, and it seems the last item is from Jack. Do you want to describe it?
Yes, thank you. So I was having a conversation with a colleague late last week about ways to do preemptive or predictive scaling out. So the classical problem is like business hours. So in the morning, you want to make sure that you can anticipate the rate of traffic growth and scale your clusters so you're not waiting. And I was wondering if this would be a part of a solution, but I was wondering if there has been any conversations in the past around introducing the notion of a factor for in the pending pod simulations to calculate how many nodes are needed. So right now the assumption is that the factor is 1x, like there is no factor. This is my understanding, at least. Please correct me if I'm wrong. If there is some solution to do this, let me know. But I was wondering if one way you could compose a solution to this would be having a configurable factor where you could say something like 100x. And so for every pending pod, you actually simulate how many nodes you'd need for 100 of those pending pods.
So I mean, from historical perspective, there have been discussions of this going back very far. Yeah, and I see Elmiko mentioning provisioning request. So I think provisioning request is not aiming at least currently at solving exactly this scenario, but it sort of is at least in terms of like how it works. I'm not sure if you're familiar with provisioning request API.
A little bit, yeah. No, this would be I mean, that could potentially work, but something like this would be a little bit more elegant because you're not having a secondary workload description try to represent something as a kind of proxy workload. That's where you add more complexity. If you can simply create the nodes according to the pods that are running, you can maybe optimize for things like pre-caching of images and things like that. Go ahead.
I think there are two kind of aspects to this. So one is how you do this technically, and I think all the discussions and ideas so far go in some way towards essentially having in-memory balloon pod-like construct. So you just feed more pods into the bin packing simulation, right? Which is, I think, also what you propose. And it's not...
That's essentially what I'm thinking, yeah.
Yeah, it's not terribly difficult to do that. Provisioning request, I believe, is doing this, right? So there is a precedent here, and yeah, that's so implementation-wise, it's not that difficult. I think the challenge has been the API, and part of the discussion around provisioning request is, can it be brought into a more generic API? I think the reason it haven't happened before is we didn't come up with API that is significantly better than just creating balloon pods. And so kind of the motivation to implement something wasn't there, just because you can already do that with balloon pods with a bit of hassle, admittedly, right? But you can have a balloon deployment that's controlled by HPA, that's fed by a custom metric that is based on some other like size of deployment or whatever other thing you want to use. And it's not the most convenient solution, but then it's difficult to come up with good general API. However, since we are literally right now having the discussions around provisioning requests, I think that could be very interesting point to bring into this discussion. I think specifically for like percentage-wise, because it's been quite common request to do like 10% extra. I think 10% extra of a workload is fairly easy. You just add 10% more pods. I think it's difficult to have an all semantic there. So it's easy for like one specific workload. But if I have 50 workloads, do I want to have 50 buffers? Is the difficult question. And if not, how do I translate 50 workloads into one buffer somehow? So that has been one challenge. But
okay, this is all good feedback. I can do some homework on what you've suggested and see if, in fact, it's nearer to the solution than I assume. And also, I would want to involve Carpenter in this, because I think there's a similar gap in the way that Carpenter behaves as well. It'd be nice to land in a single.
Yeah, so this is I think also why I mentioned provisioning requests and those discussions, right? Because we are discussing specifically with Carpenter team. So I think if we can come up with one API that works everywhere, that would
for
be
sure.
better. And I'm not saying provisioning request is this API. I'm just saying maybe we can come up with one API. Maybe it turns out the API is just an annotation on deployment. I don't know, but then it would be very nice if it's the same annotation, right?
100%.
And I think it's similar enough use case. Then maybe we can just discuss it as one problem space and then come up with the solution.
Great. Cool. Thanks for the time. Thanks for adding that, Mike, into the chat.
Yeah. Okay, I think we moved to the entire agenda. Does anyone have any other last minute topics that you want to bring up in the last minute that we have? Okay, in that case, thank you everyone, and have a good week. See you in next week or tomorrow if you're interested in AWS template nodes discussions. Thanks. Bye.
Bye.
Thanks.
Bye, thanks.